Thank you for allowing me to give you an overview and a brief demonstration of Micro Focus's Modernization Workbench, which is recognized as the leading solution for extracting business and technical intelligence from existing application portfolios. My name is Rick Wygant, and I'm a Senior Solution Engineer with Micro Focus. As I just mentioned, the Modernization Workbench extracts business and technical intelligence from your existing enterprise applications. Now, this intelligence is kept current and up to date in a central repository. With the Modernization Workbench, you can gain an understanding of the business intelligence of the applications that run your business, which can guide you in making management decisions. The Modernization Workbench will provide you with deep technical insights into your application's architecture and behavior, which will improve the quality of the applications and time to market. And as I stated previously, this information is stored in a central repository based on either Oracle or DB2. This provides you with up-to-date information that promotes collaboration across your teams, whether they be local or global. And finally, the Modernization Workbench Central Repository is populated from multiple information sources, which I'll describe in more detail in a few moments. Not only does this ensure that you are getting the right information from the right places about your applications, but it also ensures that the right information is available for all the stakeholders. Now, the Modernization Workbench is made up of a suite of tools. This suite of tools sits on top of this central repository I just spoke about, which is populated by the multiple information sources I just mentioned. According to the industry analysts, all three of these categories of source are required for organizations to adequately make fact-based portfolio decisions. The parsers extract technical information from the source code to get such things as inventory of the artifacts, dependencies, relationships, as well as calculations for industry standard metrics such as McCabe's cyclomatic complexity, Halstead's software science volume metric, and the SEI maintainability index, and several industry standard object-oriented metrics. The external data or business information comes from other sources and contains information about the applications like performance, defects, change traffic, problem tickets, cost, or just about any other type of information that is pertinent to you making decisions about your applications. And finally, surveys allow us to extract subjective information from those that use the applications on a regular basis or who are the subject matter experts. Things such as applications' business or strategic value, mission critical value, ease of use, or other subjective information based on their personal experiences with the applications. These multiple sources of information feed the repository, which is now the single point of truth for making fact-based decisions about your application portfolio. Sitting on top of this repository are the 5 modules that make up the Modernization Workbench, which are Enterprise View, Application Analyzer, Analyzer Express, the Business Role Manager, and Application Architect. I'll explain each of these more in a moment. These tools will assist in understanding your portfolio at multiple levels, from helping business users match IT priorities with business priorities, to technical users being able to quickly translate business requirements into development actions. In other words, whether you are planning for modernization, a migration, innovation, or overall management of your application portfolio, the Modernization Workbench will give you the understanding and control you need to move in any of these directions. Now let's review the 5 modules that make up the Modernization Workbench. Enterprise View is the application portfolio management module of the Workbench suite that provides you with high-level dashboards and reports that can guide you in making your portfolio management decisions. Application Analyzer is the module that provides you with that deep technical insight into your applications. Analyzer Express provides the day-to-day developers with immediate access to much of the same analytics provided by Application Analyzer, but in an Eclipse environment. The Business Role Manager gives you the capability to uncover the business logic within your applications to better understand its behavior and allow you to gain control of that logic. And finally, Application Architect helps you transition applications that you may be considering for renovation or a new architecture by providing capabilities such as identifying and eliminating dead and non-standard code, as well as creating reusable elements of business logic if you are considering a move to service-oriented architecture. And now I'll provide a brief demonstration of one of the modules of the Modernization Workbench, Application Analyzer. Using the suite of tools contained within the Modernization Workbench, there are a number of different approaches that can be used to begin to understand your applications. For example, through the use of Enterprise View and high-level dashboards, one approach is to use a top-down analysis to first focus on general areas of interest within your applications and then drill deeper into those areas. This approach is prevalent in application portfolio management and is often used at the executive or management levels of the organization. Another approach, which is the approach I'll use for our demonstration today, is to use Application Analyzer for a bottoms-up analysis for application discovery and understanding. This approach may be used by developers, architects, project managers, or technical management to gain a deeper understanding of the applications. I'll break this demonstration down into three components to give you a taste of three primary analysis techniques available through the use of Application Analyzer. This will be just touching the tip of the iceberg of what Application Analyzer can do for you, but you should see how quickly you can begin to get a deep understanding of your applications through the use of this tool. First, we'll quickly review the results of the automated parsing and analysis that was done to populate the repository with the application artifacts. Secondly, we'll come up a level and through the use of diagrams show how easily we can understand the relationships and dependencies as a means to better understand our applications. And finally, we'll come up one more level of abstraction and show how we can organize our applications in a way that helps us to manage the portfolio based on things like business or technical functionality, by department or by project, or organized in just about any way that makes sense to better understand and manage these applications and their components. Now, as we go through these three steps, I'll show you multiple ways that Application Analyzer provides you with a very flexible environment that allows you to efficiently analyze and understand your applications through such things as queries, impact analysis, traversing through the source code, and a number of other time-saving facilities. We're now looking at the Modernization Workbench and specifically Application Analyzer. The tree view on the left is a list of projects, which are just logical views of the artifacts in the repository. In other words, there is only one version of the source code in the repository, but there are multiple logical views to the same information and are represented by the projects listed in the tree structure. For our demonstration today, we're going to work with only one of these projects or logical views, which is demo training. You can see the individual file types in demo training such as BMS maps, COBOL files, copybooks, and so on. This shows the types of files that were parsed and analyzed during the initial load of the source code into the repository. From this automated analysis, we would get an understanding of what exists in our applications and a breakdown of the different types of information as we see here and how it is spread out across our applications, including various relationships and dependencies. Let's first begin to look at some reports as a means to quickly review what we have in the repository. In the Prepare menu, we'll see a number of reports, and we'll first look at our inventory report to see an overview of what artifacts are in the repository. This report gives a snapshot of the entire workspace or all projects that we have in the repository, but we'll specifically look at the project that we're analyzing today, which is demo training. So what we can do is we can look at the breakdown of artifacts here, and then we see different specific metrics and information about those artifacts just to give us an overview of what we have in the repository. So as we look at demo training, we can see the different components and see things like the size, the source lines, the number of components, and so on and so forth. Now, as is the case with all reports and diagrams within the Modernization Workbench, we can save any of them to multiple industry standard formats for later retrieval or for propagating to others in the organization. So as we'll see here, we can save it in a number of different formats. As I mentioned earlier, there are a number of industry standard metrics that are calculated during the automated analysis of the source code. There are approximately 180 different types of metrics that are calculated, but let's take a look at a few that will give us insight into the complexity and maintainability of our applications. This allows us to begin to focus on possible areas of interest for risk and exposure. So as we can see from this report, we see a number of different metrics that are calculated. We can see the standard metrics like lines of code, program length, but now we see the cyclomatic complexity. This is the McCabe industry standard metric. And we see the maintainability index. Further to the right, we can begin to see the deadlines of code, conditional statements, things that would indicate the complexity, or when it comes to the maintainability index, the maintainability of these applications. We see the application names on the left, and then we can go ahead and sort. And the cyclomatic complexity, the lower the number, that means the less complex it is. So we'll begin to look at the more complex programs. For example, we see Order Ent 1, which is a program of interest for our demonstration today, that is fairly complex. Anything above 50 would be considered possibly complex to maintain. And then we can also go to the maintainability index, which is another industry standard metric, and the lower the number, the more difficult it is to maintain. So from this report, we can quickly see things like the complexity and the maintainability and a number of other metrics that we could configure within this report as well. There are a number of other reports that provide additional information about the contents of the repository. For example, the CRUD report, CRUD standing for Create, Read, Update, and Delete. The CRUD report for a project shows the data operations for each program in the project performs and the data objects on which the programs operate. This report is sort of like the one-stop shop for all the I/O activity that may be occurring by determining the data operations and program to data object relationships and displaying them in the CRUD report. The reference reports, which actually consists of 3 separate reports and are used primarily to facilitate the build and ensure completeness, basically telling you which things are extra or which things are missing in the repository. For example, Program A is calling Program B, but Program B does not yet exist in the repository. There is also a cross-reference report that gives you a very high-level cross-reference of all the references between the different artifacts that are in the repository. The final report I want to show you is the Executive Report, which provides you with a central location for many of the standard reports in Application Analyzer, as well as other information about the repository. It's an HTML version of a report that can be easily packaged and delivered to others in the organization to help assess the risk and cost of supporting the application. So as you can see from the report, we see many of the standard metrics that we already discussed, as well as a number of other metrics and an analysis of anomalies within the repository. On the right, we see some of the standard metrics that you would see regarding the repository, as well as dashboards. In all these areas, you can dig deeper to find additional information about the artifacts in the repository. Before we look at some of the high-level tools that allow us to begin to get our arms around our applications, let's quickly jump right into the details to get an idea of the types of information that is extracted by the parsers. Let's start by looking at one application that is a COBOL program called Order Ent 1. We saw the complexity report indicating that this may be a complex program that's difficult to maintain. As we expand the tree view under this program, we can see that the parser identified all these entities and relationships as the program was analyzed. So you can very easily begin to identify and understand the specific interactions this program has with other entities. When you right-click on an object, you can see that with a minimum number of clicks, you can get to the answers or information you are looking for very quickly. Let's take a quick look at querying the repository to hone in on key relationships of an object. We'll look at all the direct references to the program Order Ent 1. Through the query facility, you can get things such as all the programs that call another program, or all the programs that update a data store, for example. From the results, you can launch further queries without having to return to the repository browser. You can then create printable relationship reports and export them to a variety of standard formats. Now that I've shown you some of the details and facilities that Application Analyzer provides to look at your applications at a very granular level, let's step back a moment and look at some of the capabilities that allow you to look at a higher level of the portfolio so you can better target where you need to do further analysis at this granular level. Imagine for a moment that you are looking at a complex application for the first time, and you are now responsible for making changes to it. Or consider for a moment if the organization is about to lose its knowledge base from individuals retiring and new people have to be brought up to speed on those applications in the quickest time possible. Through the use of diagrams, you can view the relationships between application objects interactively. These relationships describe the ways in which program objects interact. I'll show an example of this by looking at a call map diagram for the demo training project, showing how the programs call each other. I'll do this by selecting Call Map from the Scope drop-down menu at the top, which simply determines the objects and relationships represented in the diagram. Once the diagram is displayed, there are many tools available that allow me to efficiently operate on this diagram. For example, there are multiple layouts for displaying the diagram. You can also manipulate the diagram for layouts that suit you best. You can zoom into areas of interest or quickly revert back to the original diagram. You can also save this diagram in many industry standard formats such as Visio, or you could save this diagram just as an image. So this graphically allows me to view this application in many ways. But if at any point in time I want to drill into any of these elements, it's as simple as a mouse click to view such things as properties. With the Properties feature, I can do this from just about anywhere within Application Analyzer, which offers convenient ways to navigate program code and relationships. So as I did Properties on our Order and One program, I can see that it is a program. I can look at the general description of this program, where it's located on my system. I can go to the Statistics tab and I can see specific statistics and metrics about this program. For example, complexity. I can begin to see some of the metrics that we looked at in the metrics report. I can see additional information as well. For example, dead data elements, dead lines, so on and so forth. By looking at the Relationships tab, I can see the same relationships that we saw before in the repository browser, so I am now back down to that granular level of analysis. I can continue clicking in these different levels of relationships and continue my path of deep analysis of my applications. In other words, it's very easy to start investigating these high-level relationships. If I don't want to see the entire diagram, I can build it incrementally so I can focus on areas of interest and not be overwhelmed initially with a large complex diagram. I'll demonstrate this by using the Auto Expand feature in Application Analyzer. As you can see, we currently have Auto Expand turned on. So using our Order End program as our example, we'll generate a CICS flow diagram for this program. To do that, I can simply change the scope to CICS flow and redraw the diagram. And we get a fairly complex diagram since I have Auto Expand turned on. So now I'll go and turn Auto Expand off. I'll clear our diagram. And now to create this incrementally, I'll simply select our Order End program, do a Control C to copy it. I'll paste it in our diagramming area by doing a Control V, and we can now see we get a much simpler diagram. Now to expand this diagram further, I'll start with my screen object, and I want to see all other programs that call this screen. So I'll expand incoming. I'll look at our inventory program. I'll expand it to all our outgoing. And so as you can see, I can begin to build this diagram incrementally instead of being overwhelmed with that initial diagram I had when I had auto expand turned on. Now that we've explored the overall architecture of the application, I now want to understand a bit more about what's underneath the architecture by looking at such things as programs and procedure flows, as well as data flows. I may also want to navigate through the source code and possibly create a glossary or even determine the impact of changes I'm considering. I'll demonstrate a few of these interactive capabilities by going into interactive analysis, also known as Hyperview, for our order end program. The initial configuration I have displayed for interactive analysis shows the context pane and the source pane. There are many different panes, and I'll show a few more in a moment. But the panes you do have displayed and how they are laid out on the screen is completely configurable by the user. The context pane on the left displays the parse tree for the selected source file, which in this case is order end1. It displays source code constructs in a hierarchical form, making it easy to locate constructs quickly. The constructs are displayed in the order they appear in your code. So as you can see, when I select 1200 edit order data, I see that represented in the source code on the right. As I expand that view, I can continue to select areas I want to see very quickly in the source code. And likewise, when I select an area in the source code, it's represented in the context pane as well. The source pane is context sensitive as well, so anywhere I'm located in the source pane, I can right click and get a number of different options. For example, for this paragraph, I want to see the perform statement that's calling it. Once I'm at the perform statement, I can right click on it and I can see the called paragraph. For variables, I can right click and I can see the declaration for that variable. Or on the other hand, when I'm at that variable, I can right click and I can see the instances for that variable. So you can see there's a number of different facilities within the source pane that make it easy to traverse through the source code. I now want to take a closer look at specifically the paragraph or procedure flows within this program. To do that, I'm going to open up the flowchart pane. The flowchart pane displays a statement flow diagram for the paragraph or procedure selected in the source or context pane. So I'm going to select 1200, edit order data, and I now got a flowchart showing the flow. And the flowchart pane is context sensitive as well, so where I select within the flowchart will be represented both in the context pane and the source code pane. Now as I continue my analysis, I want to see just the paragraph call flow for this COBOL program. To do that, I'm going to view my Kali pane. The Kali pane displays a diagram that shows the call flow for paragraphs or procedures in a program. The flow is traced from a seed item to a called external program, subroutine, or procedure if there are any. Now to get a better view of this diagram, as with any of these panes, I can click on the top blue bar and get a full view of it. And I can also configure the depth or the number of levels I want to go to in this diagram through the user preferences. Internal items are displayed with a black border. External items are displayed with a red border. And also the relationship lines based on the color indicate control of the flow. For example, green is a go-to, red is a perform, and black is a fall through. So through this diagram we can specifically see the paragraph flow for this program starting at any seed item, and again we can configure the depth of what we want to see. And as with the other panes, anywhere we click within the Kali pane, it's reflected in the other panes that are displayed. Now I'll clean up my screen a bit to show you one final capability within interactive analysis. So I'm going to turn off my Kali pane. I'm going to go ahead and turn off my flowchart pane, and I'll clean up my context pane. Now we're quickly going to look at Clipper, which is an advanced search engine within Application Analyzer. I'll go ahead and open up my Clipper pane. Because we are modeling the information about applications to a very low level of detail, the Clipper search engine can provide very advanced low-level searches and queries. As you can see, there are many categories of queries that come with the base product, each of which can easily be modified, or you can also create your own Clipper queries from scratch. In most cases, though, you should be able to find a similar query to what you might want to do and just modify it. And I'll quickly show you what a query might look like. Dead statements, not in dead paragraphs. So this query was created. If we want to modify this query, we simply go in, select one of the statements, and then we'll see all the options, plus a help for each one of those options on how that construct might be used in this case. I can then go ahead and run this query, either to list the sources only or to find all the constructs. I'll go ahead and run this query and find all the constructs. I see that there were 6 constructs found. My results are in the Clipper pane to the left, and then I can begin my analysis by looking at the constructs that were brought back in the results. And then again, it's context sensitive, so I can go directly to those constructs of interest. That brings us to the end of the second step in our bottoms-up analysis demonstration, where we looked at diagrams to assist us in focusing on specific areas of interest. So now we come up one more level of abstraction and look at the logical organization of our applications based on high-level business or technical criteria. Within Application Analyzer, we can define informational hierarchies. For example, I may start out and say within my enterprise I have a variety of departments, and within each department I have one or more applications. Or maybe the information that's important to me has to do with my project management office. Or maybe I want to see a functional decomposition of my claims process in an insurance company, and I want to see all the discrete processes within that claims function. On the left side of the screen is the logical hierarchy that we're going to use for this demonstration. I'm going to show you some of the benefits of using this type of hierarchy in an analysis process. So what we have here is we have the enterprise that's made up of 3 primary departments: finance, human resources, and sales. And then within each one of these departments are additional business functions such as accounting, payroll, and the customer relationship management system. This screen may look familiar to you because this is where we were at when we first started creating diagrams. If you recall, we created a diagram with a call map scope, which you'll still see in the scope box at the top of the screen. This time though, we're going to select in the group by drop down box enterprise. So now we want to see our programs organized by that hierarchy that I showed you just a moment ago. Now that I've selected enterprise, I'm going to go ahead and draw my diagram. And now what we see here is the highest level in that grouping of enterprise. And within enterprise, we see enterprise sales, enterprise HR, and enterprise finance. So now that I'm looking at my application based on a departmental breakdown, I can expand one of these departments and see the components within it, which allows me to be very focused in my analysis. So I'll expand enterprise sales, and I can begin to see the component breakdown within enterprise sales and how they relate to the other departments within my enterprise. I could break it down further by looking at enterprise finance, and now I begin to see a little more complex of a diagram, and I can continue to do this and see all my departments, and even within a department I can have sub-departments or subgroupings as well, like I have here in HR. I have HR payroll, and then I can break it down further and see the components within HR payroll. As I expand these other departments, I begin to see how this diagram could have been very complex if I had not had this departmental structure in place. Now I could start working with this diagram by using my tools, begin to zoom in and focus in different areas, or I could collapse these departmental groupings to allow me to get a less complicated diagram. And just as I've been showing throughout this demonstration, you can drill down into any of the components within these groupings. And finally, as we went through this bottoms-up analysis of our application, we continuously went to a higher level of abstraction when viewing various components of the repository. This process of going to a higher level of abstraction can continue by populating high-level dashboards with not only the technical data that we have been reviewing, but also with the other two sources of information being surveys and other external systems. Then, through the use of these dashboards, we can make decisions about cost and risk and determine where our exposure is, and then drill down to the specific areas of interest and view the technical data for further analysis as we did in our demonstration. Thank you for taking the time to view this presentation and demonstration of the Application Analyzer, one of the modules of Micro Focus's Modernization Workbench.